Hello, my name is Francis McShane, and I've written a SketchUp Ruby plugin called WinDoor based on Atlast's parametric class. If you've used the window plugin that comes shipped with SketchUp, it's a child of the parametric class, and you'll know that windows created using the window plugin are created and edited with dialog boxes, and that the window object retains the parameters that you've entered into the dialog boxes. Well, the WinDoor program that I've written allows you to create complex window and door arrangements and more realistic windows for the British and European market. Again, is based on the parametric class, so it will be the windows will be created and edited using dialog boxes. So let's just get on with it. I'll make a kind of a box that's sort of like a building into which to place the windows. Now, if you've correctly installed WinDoor, you'll find it under the Tools menu, and there it is, WinDoor. We'll just use these default values that are in the dialog boxes just to get ourselves started. Make the second one a door. And just having accepted absolutely standard values, I've created already quite a complicated looking WinDoor object. I'll move this figure inside the box so that you can see the glazing a little bit better. You can see that the things are transparent. And I'll select the object, and if I right click on it, the context menu should come up with this edit WinDoor option. And now you see what this first dialog box was about, ABA. It's the arrangement of individual elements within the complex object ABA. Okay, and the overall height's 2.4 meters by 21 wide. I can check that. No, it can't. It's not transparent. Sorry, but it is indeed 24 by 21. I know that. And we will edit the window element A, and we'll not change its profile dimensions, although you could. I'll let you play with that on your own. And you've got a range of frame colors you can pick from. You can pick a different frame color if you like, and we can change its height. You can also change its width, but if you change its width, that will affect the overall width of the component, and so this 2.4 meter width becomes a little bit harder to maintain. So we'll just leave it at that for now, but we could make it say 1200 high, and we'll give it a mullion and a transom. Further down you'll see mullion space and transom space, and they're ignored initially because our transoms and mullions are equally spaced and symmetrical. But if you were to choose one of these 8 options here where transoms and mullions are not equally spaced and symmetrical but are eccentric and asymmetrical, then these values would become important. And it's only because transoms and mullions are equally spaced and symmetrical that they're ignored initially. So we'll just OK that. We'll edit the door, and you can see how the color changed to beige. We'll make it not a single plain door but a single panel door. Accept the profile dimensions. Just accept the brown color. We'll make it the correct height for a door, 2100. We'll give it 1 mullion, which is the vertical element, and 2 transoms, which are the horizontal elements, and we'll OK that. And so you can see we've got 2 beige windows and a brown door, and as an architect, apart from the colours being a bit weird, but they're only there just to illustrate them, this transom doesn't match up with these transoms. So you could either lift this or drop these. What I'll do is I'll lift this transom up to match these transoms, and we do that using that tartan grid effect that I spoke about earlier, where the transoms are going to be set eccentric and asymmetrical, and the degree that you set them, the transom spacing will depend on this dimension here. Basically, we're going to go up vertically and try and match in with that. That's 1340 high. This is 641.7 high. So that has to get a bit higher to bring that up into line, obviously. And the degree that it has to get higher is the half of that, of 181.7, say 182 roughly. 181. Well, we'll do it exactly actually. 181.7. Use the calculator. So it's 181.7 over 2 is 90.85. So that's definitely 90. It only does it to single figures. It won't do it to two figures. So it's 90.8. Say that I have to add to what these are already. 90.8, and these are already 516.7, so they will become plus 516.7, so they'll become 607.5. okay, so let's edit that now. We'll not edit A, but we will edit B. And the transom spacing will become 607.5, and it will be transoms eccentric and asymmetrical, mullions equally spaced and symmetrical. So just OK that, and there you go. The bottom lines line through, which is good. You could actually make these widths the same, but that would be probably mostly for doors. They are wider, so that would be a more usual arrangement for a door. I suppose you could have centered it so that the center of this lines up with the center of this, but you can play around with that yourself. What you might actually want to do is make, say, panes 1 and 3 into opening lights, and that's very simple to do. And also you might want to fill in these door panels so they're solid, 1, 0, 4 and 3, and maybe frame up the glass here so that it doesn't look like it's just stuck into the outside frames, but has a bit of glass retaining strip around it. So we'll do that. And they were panes 1 and 3. Pane 1 is a casement, and 3 is a casement. Okay, and it was 0, 1, 3 and 4. 0 is a spandrel, 1 is a spandrel, 3 is a spandrel, and 4 is a spandrel, and 2 is a casement, and 5 is a casement. Just double check that. Yeah, 2 and 5 are to become casements. We'll just OK that. And so there you go. We now have these are opening casements, these are spandrel panels, and these are glazed with a bit of framing around them. And if you just move that around, you can see through the glass there. I think you can agree that you can see through the glass. There's the girl behind it. Now, the next thing you might want to look at is this pattern of windows and doors that we've created, and we can obviously add to that. I'll keep it symmetrical. We can add a window element there. If I just go OK. One word of warning with adding stuff, and that is this width. Then it's just the same as if you change the width of individual elements. The width becomes a little bit kind of it may or may not work. I'm just admitting that at this stage. At a later issue of the program, I might have rationalized that a little bit so that you can give priority to certain window elements and maybe retain that width if it's possible. So we've edited that enough, window element A and B. We don't want to edit that anymore either, but we want to create our window element C, and it will accept again the profile dimensions. We'll just accept the standard frame color, and we'll make it a deeper window. Make it 1800. And I see here that it has attempted to do something with the width to bring it into line. I don't think it's going to work, so I think we'll just give it a particular width, which is half the previous window element widths. They were 800, so we'll make this 400. We'll not give it any mullions, but we'll give it one transom. We'll just see what that does. And there you go, it's 1800 tall. Which is quite an interesting, but might be nice to bring that transom up in line here and maybe turn this into an opening light. So again, we do it just by measuring this. This is easier than the last one because it doesn't have two transoms, it only has one transom. So it has to go up to 1095. It has to go up to 1095. I think we'll change the colour of it to the beige again, make it fit in with the other windows at least. And the transom spacing has to go to 1095, and they will not be transoms equally spaced and symmetrical, but there will be transoms eccentric and asymmetrical. And then also we want to make the top one a pane, so that's one. Casement 1 will become, sorry, not a pane but a casement. Yeah. We're happy enough with that. So, I made the 0 a casement, not the 1, sorry. That was just a little slip there. Yeah, I made the casement 0 into a casement. It should have been 1, beg your pardon. There you go, that's better. So all these top ones are casements. They all line up, and that lines up, the bottoms line up with the bottom of the door transom. That looks quite interesting. What I'm going to do now is, well, first of all, show you that if you don't like the schedule information that's on the drawing, you can just switch that off using the layer dialog box. I'll put back one of these, yeah, those, because it's actually quite useful to have the pane, the information of the individual panes. But that shows you how you can switch it off if you want. And you'll need both, obviously, for a schedule if you're drawing a schedule. What I thought I'd show you, maybe I'll just widen that a bit to fit a wider window on, is if we play around with that tartan grid aspect of the program. So we'll call up the Windows program again, and we'll just have a single element, an A. I suppose if you were scheduling, you wouldn't want to call it A because I think the door's A, or that window, sorry, is an A. So we have an A, B, and a C. We'll make this a D. So this is a completely different element. You could call it an A. It won't crash the program. It's just then you'll suddenly have two different elements called A in your drawing. And we'll leave it wide. Keep it a window. And we'll give it 2 mullions, maybe even 3 mullions. And 2 transoms, because we're going to just see what effect these elements down here have. So we'll just OK that for now, just to see what kind of a window we have initially. There you go. And we'll start editing it using only the tartan grid drop down list. That's this one. So let's make it transoms and mullions at eccentric and asymmetrical. So just OK that. So you can see that 250mm distance comes into its own. Then these panes are all 250 wide, okay, and the whole thing's eccentric and asymmetrical. So that produces quite an interesting looking window, but not an everyday one, that's for sure. We'll edit it again. and we'll make it go to the next one. Just work our way through these, and here you can see that they're symmetrical but eccentric. They're symmetrical but eccentric. We'll edit it again. Yeah, eccentric and symmetrical. This one will only affect the transoms. I think we've seen that before. Yeah, the transoms are now asymmetrical and eccentric, but the mullions are symmetrical and centered. And so you can go through it. And the other thing that you can do with this is you can still put in spandrel panels and casements, and that's quite useful. Go to the next one. We'll just take a look at, let's say you wanted 6 and 11, or say the whole row, the whole top row to be opening casements, and the whole bottom row to be spandrel panels. We'll see what happens when we do that. So that's 6, 7, 8 and 11 are casements. 6 casement, 7 casement, 6, 7, 8 casement, and 11. I can get at it. Just about 11 casement. Yep, 11, 8, 7 and 6 are casements, and 0, 1, 2 and 9 are to be spandrels. So 0 is a spandrel, 1 is a spandrel, 2 is a spandrel, and 9 is a spandrel. Okay, we'll OK that. So, oops, 0, 1, 2 and 9 are spandrels, but they shouldn't have been. It should have been 0, 3, 4 and 9. And that the reason that's happened is because the arrangement of the windows got changed. I should have actually changed the tartan grid first and then set the window opens. That is a little bit of a glitch in the program, that it as it rearranges the window, it also rearranges the actual the panes, but we'll fix that fairly quickly. So in this instance it's 2, 7, 8 and 11. 2, 7, 8 and 11 that you want to be casements. So here we go. 2, 7, casement is a casement, 8, and 2, 7, 8 and 11 are casements. They are 2, 7, 8 and 11. 11's a casement, yeah. And then 1 and 6 are just panes. I'll just get rid of those. So 6 is a pane, 1 is a pane, and 1 and 6 are panes, and then it's 0, 3, 4 and 9 that are spandrels. So it's 0, 3, 4 and 9 that are spandrels. 9's a spandrel. 0, 3, 4 and 9 are spandrels. Just double check that again. Spandrel, 0. 1 should be a pane, shouldn't it? Yep, 1's a pane. 0, 3's a spandrel, 4's a spandrel, and 9's a spandrel. Well, we'll see how that goes. There's an awful lot of things here, but it seems to have worked fine. Yeah. So there you go. That's an opening light, an opening light, an opening light, an opening light. These are just fixed panes, and these are all spandrels. So so we can go through it. We'll do one more just for the hell of it. It will probably mess up our spandrels and all the rest of it, but it will give you a different tartan grid. So you basically set your tartan grid first, then set your opening lights and spandrel positions. But it does show you how you can build up much more complex windows. First of all, using the tartan grid function, and then this assembly function that the program gives you. Hope you found that useful and that you enjoy using WinDoor. Thanks for listening to the video.